promised, here's regex for noobs. You all have several ways of contacting me, so we won't spend too much time on that. But we will start talking about first is just what is regex, because we're kind of assuming, hey, if you're a noob, you don't know any of this. So let's just be real clear. It's short for regular expression. If you didn't know that, it's a clipped compound regular X expression. But what they really are, they're just sequences of characters that define a search pattern of types. So what that really means is if you're trying to work with strings of text, these are patterns that help you search for them. They're handy for doing things like extracting text from log files, validating user input, and then doing actual string manipulation. And I'm going to show you a ton of examples of how all of this works. Obviously, most of these examples are going to be in PowerShell, which you're largely familiar with, I think, and you're probably already using regular expressions. If you've ever done something like this where you've just got an array of strings, maybe this is a bunch of usernames or something, and you want to filter them for the ones that match a specific pattern. In this particular case, this example returns the two that have the pattern something in them, because that's a regular expression. In the where object statement right there, that something is regex. And if you didn't know that, now you know. You're already a pro. You've been nailing this for years probably already. But it looks for that pattern in the things that are being piped into it. So those three items in the array. And that pattern was found in something one and something two. So it gets sent back to you. Pretty relatable example, I'm sure. And obviously, as we're kind of working in PowerShell here to set the stage, this is mostly just using the match operator, and it returns a Boolean value. It's either true or false. It's either going to find the pattern on the right in the string on the left, right? That's just how this works. This one returns true because it's looking for this pattern something. On the right, the regular expression. On the left, the string that it's taking in. Very important level setting to kind of put in here. And so if you give it a pattern that isn't found, it returns false, obviously, because that pattern, the word pickles, is not in that string. Quickly, we'll cover kind of simple replacements. This is obviously PowerShell specific, but there's equivalent operations in like every language. This takes a string on the left of replace. Apologies that it wraps around, but I just pretend this is all one line. Here's the simple string. That's the string that we're working with. That's kind of like our source data. And then let me switch to laser pointer just to make it easier here. This simple string, this argument, the first one before the comma, that's the regular expression here. And then this argument that comes after the comma is what we're trying to replace this pattern with. So we're going to look through that string and replace it.
So typically, I'm questioning here. So is the question the idea that it's mainly, it doesn't use like the wildcards at the end? So a lot of that kind of text expressions, you like star. So with regular expressions, you don't use any of that, or is that you're going to get to that later?
We're going to get to what some of the special characters mean for sure. Cool. I just want to do a little level setting with some of the tools that the rest of the presentation kind of looks at. So in this case, the green highlighted area is the regular expression. The blue highlighted area is what we're replacing it with. So we found it here and we replaced it with the blue thing. So we got this out of it. And now to talk about, actually, we're going to talk about the star character first. Quantifiers are used in regular expressions to kind of save you from having to specify exactly how many of a thing in a row you want. It'll make a little more sense in an example here. So here we have, it looks almost exactly the same as some of our other examples, right? We have string on the left, and then we're seeing if the pattern on the right is found in it. And so if this was just a wildcard, this would technically, actually, no, this would be true still, because the absence of something is still okay with the wildcard. But the star has a different meaning in a regular expression. A quantifier, all of them, the star included, apply to whatever comes immediately before them. and are used to denote how many of the thing that comes before them you're looking for in your pattern. And so what this regular expression says, which returns true, by the way, is looking for an S. And then, whoa, not just an S, we're looking for 0 or more S's, and then the rest of the string here. And in our pattern, we have 0 or more S's, and then the rest of the string here again. And so we say, okay, yep, found that pattern this is the match. This is everything that matched our pattern. So what do you think this one does? This is either going to return true or false. We have our same input here, but we've slightly changed the regular expression we're using. If this is a wildcard, then this should return false because it's going to look for Q and then the wildcard and then the rest of the string, right? But it's a regular expression. So this returns true. And that's weird. You might not have seen that coming because we've got a Q and 0 or more of them. We want Q and 0 or more of the thing that comes before the star, and then the rest of your string. So we're saying there's the rest of the string, and 0 or more, well, there's 0 or more right there. So this matches. This is the match. This S ends up being irrelevant. It doesn't need to match the entire string. It doesn't have to be an exact match, but it's just saying that this pattern was found in this input, and for the record, here it was. And so if you do something like this, where you just leave this front character off entirely, that returns true, because it's the same pattern, 0 or more Qs, and then the rest of the string. And we have the rest of the string, and guess what's before it? 0 or more Qs. Makes sense. The plus symbol is another quantifier, which works a lot like the star, except instead of 0 or more, it means 1 or more. So you get scenarios like this where this returns true because we're looking for 1 or more S's, right? It applies to the thing that comes right before it. So S, 1 or more S's, and then the rest of the string. We got the rest of the string and 1 or more S's. So that's a match. That's why this returns true, right? How about this one? Well, it's false. Well, in the previous, if that was a star, this is true. But since it's a plus, it's false because we're looking for 1 or more Qs and then the rest of the string. And we got the rest of the string, but we don't have 1 or more Qs that come before it. There's just an S there, right? And so no match. How about this one where we omit the first string completely, or the first letter completely? That one's false too, because we need the rest of the string. We got the rest of the string, but we don't have 1 or more S that comes before it, right? So that's why this one's false, because instead of 0 or more, this means 1 or more. And then one last example here. This is exact same as the one before it. There's no S there. There's no character there at all. There's no Q there either, so it's false. I keep motoring here because we've got a lot to cover. Question mark means 0 or 1, so it's not going to match a whole bunch in a row. But since we're just doing Boolean matching, this actually ends up working a lot like the star. It's just kind of a nuance that you'd be familiar with, and when you kind of bump into it more, you'd appreciate knowing. This one's true. That's our rest of our string still. This is 0 or 1 S. There's our 0 or 1 S. There's the rest of the string, right? So there's our match. And same thing here, 0 or 1 Q. There's the rest of our string. There's the string. And then this kind of underlined area is just denoting that, hey, right there, there is 0 or 1 Q. There's 0 of them there, so that's fine. So that matches. And then 0 or 1, that's true, same thing. Looking for the string, and then, hey, I guess there's technically 0 or 1 S right there. There's 0 of them. So that matches. And then this one's the exact same. I'm just going to skip this. So that's quantifiers. Or do we have a bunch of questions?
So when you say 0 or 1, like in your last example, and there was no S there, doesn't that really mean that matches on anything?
No, because it also requires the rest of the string to come there too.
Okay.
So it's saying you can have an S and then the rest of this string. Does that make sense? Here, let me back up to
Yeah,
one that's got
so
highlighted here. So
left
in this
side doesn't.
example, the one that's highlighted right now,
Mhm.
we're looking for the blue part in a literal way, right? Like these are just the literal letter O, M, E, T, H, I, N, G. Like that's
Yep.
just literal letters that we're looking for, and we found them. And before that, we're looking for 0 or 1 cues followed by the rest of the pattern. And so we did find 0 or 1 cues, and then the rest of the pattern is right there.
Mhm. I understand that it's a two-parter, but I was basically saying that 0 or 1 basically means on the left side, anything could be there, and it's going to match at least on the left side.
Yeah, that's right. The only difference it really makes for you is in an example like this where it is present, this S is found right here. So it's going to be part of your match.
Okay.
So when we start looking at other examples that aren't just true or false, but actually use the value that's getting matched, that can become important. Like if you want to keep the first letter of an account name, but only if it's S or something. That's a bit of an arbitrary example, but that's when it's useful. It is not necessarily for the Boolean matching stuff, but when you want to work with the value.
So yeah, even if it's, there's something at the end, it would still match because that all part there. So if you had, the word something text space, blah, 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 it would still match so long as it found that in the whole thing. So that's kind of the little lesson here.
Yeah, and you'll see some of that as we kind of move on too. Okay. There we go. So special symbols, this is where stuff kind of starts getting a little wonky. And like so far, they've all pretty much looked like English, and they've been somewhat readable. Like, yeah, sometimes we intermix a star, a plus, or something into the regular expression, but it's all like pretty straightforward so far. And here's where we're going to screw that up for you. First, special character, like, because if the star and the plus and the question mark are all special characters too. You saw when we looked at regular expressions that included them, we weren't trying to match a literal star character. We were matching, it had special meaning. We were matching 0 or more of the thing that came before it. And so there's a bunch of other characters and patterns that also have special meaning inside of regular expressions, and that's what we're looking at now. The first of which is the period. And it matches literally any character. So you have something like this, literally something like this. The regular expression, or first, this returns true. And you go, well, that's weird because I just said this isn't a quantifier. So literal S, literal O, M, E, that's the first part of our regular expression. And then I'm going to skip over that period and we have the literal H-I-N-G. Those don't have special meaning. Those are just literal characters. And we can see real obviously we have them. But this period must not be a literal period because for this to return true, this pattern has to be found. So this period must be special. And I just told you it was. It means any character. So we have the first part, we have the second part, and then we do have any character that occurs in between them. So this is a match. Awesome, right? Just when you thought things were getting kind of relatable and straightforward, now we start talking about the weird things that make that hard for you. That's the only example I have on that one because it matches literally anything. \n is for a new line. So like we've had ends in our patterns already. An n on its own doesn't mean anything special. It just means n. But the backslash, you're going to think of that in regular expressions as like your magic wand. And they tap anything that comes after it, and they either give it special meaning or they take special meaning away. So this n on its own doesn't have any special meaning. It's just an n. But we're tapping it with our magic backslash. And now, all together, this backslash n, the n that's been whacked with your magic wand, means new line. So it takes up the space in your expression of one character. This isn't like two new line characters or anything. This is just backslashing one n. So it's making this one n special to make it mean new line. So you have something like this. In PowerShell, this is called a here string. This entire string is wrapped in at quotes. And there's a new line right here, right? There's a line break in between. This is some multi and then line text. And then we're seeing if it matches \n. That's true because we're looking for new lines. We're looking for those ends that have been imbued with magic to indicate that they mean new line. And we have a new line right there. It's an invisible character. It doesn't actually take up width, but there's new line that says, hey, end here, start here on a new line. All right. Here's one, no new line in this, right? This just ends. There's no line continuation. The end of a line where the string terminates is not a new line character. If you don't know that, like this end of the thing here is not a new line either. So this returns false because we don't find any new lines there.
So Thomas, I'm going to pause here for 1 second. There's a pretty healthy discussion going on in the chat, and Stevie and some of the other guys are doing a really great job of helping out, but I just want to give people an opportunity. If you want to ask a question, maybe this is a good point. So is there anybody who wants to chime up and ask something that they may not understand at this point? All right, they had
Just
their
taking a look.
opportunity. Yeah,
Yeah,
help
we're going to
yourself.
talk a lot of, we're going to talk about a lot of this stuff just kind of as we go here.
I'm probably the cause of a lot of that, and I'm sorry. I was watching and thinking, and I've got a PSE window open here, so I'm just trying to figure out, like, when the thing goes between, the command interpreters and like the PowerShell script, is it switching different for escaping characters and switching? Because I guess a switch inside the shell is a dash and the thing, and these guys are doing a really great job of answering. So I didn't know.
Yeah, we'll talk a little bit about escaping as we go on here, but yeah, in PowerShell specifically, the dash is used to denote the parameter, of course, in the command, and escaping a character for the cases that we're using them in this context, as we'll keep looking at, is a very separate idea. It looks like the explanation that's going on in the chat's pretty good. And I believe Teams lets you record that too, so that should be good.
Yeah, we'll certainly try and make that available if we can.
I think it does. It depends on how you export maybe or what service it goes on. Anyway, all right, to keep moving.
Sure.
Because some of that's going to get covered as we go here. But the next special character is a lowercase d. So again, using our magic backslash to give the D some special meaning. And we have, and a D just means numbers, like 0 through 9 individual digits, right? So here we have 1, 2, 3. Do we find a digit in there? We sure did, because we're looking for this regular expression. We're just looking for a number. And then, yeah, we found it. Not only that, but we found it 1 time, 2 times, 3 times. And this is 3 separate matches here. Each character is being evaluated for this, is it a number or not? If only one of these were a number, this would still return true in PowerShell because that pattern would have been found there. So this one, there's no numbers here. There's letters and there's white space. And we're just asking, does that match that pattern? Well, no, it doesn't, because we don't have any numbers in there. Not even one of those characters is a number. However, if we look at capital D, that's right, regex is case sensitive. If we do a capital D, it's the inverse. It's not a number. So lowercase d, backslash lowercase d was for a digit. Backslash uppercase d is for anything else. It's the inverse. And this is a really common pattern in regular expressions you'll see with some of the others letters that can be given special meaning with the backslash. Is that the lowercase will mean number or other things that we'll look at, and the uppercase version is just not the lowercase version. And that'll become more apparent in more examples, but just be advised that's a pretty common pattern that you see in regex. And so in this case, same example as the first one, 1, 2, 3, does that match not a number? Well, no, because every single character in that string is a number, which is not a number. Make sense? We're looking for not numbers. These are all numbers. So therefore we didn't find this pattern here. In this one though, oh, you bet we find some not numbers. is we're looking for, oh, there is a not number, that's not a number, that's not a number, et cetera, et cetera. All of these characters match that pattern. And so, yeah, you bet, this one returns true. We found that pattern all over the place in that one. And so we'll start talking about the lowercase and uppercase equivalent, lowercase and uppercase versions of these things at the same time now. W is for word characters. You go, well, what the heck is a word character? Word character is a letter or a number or an underscore. Apparently an underscore is a word character for some reason I don't understand. But \W, we're looking for a letter, number, or underscore. \W, we're looking for not a number, not a letter, not an underscore. And so if we have this pattern here, hello, 1, 2, 3, or sorry, we have this string, hello, 1, 2, 3, and we're looking for word characters, that's true because that's our pattern. And that is a word character. That's a word character. That's a word character. These are all word characters. And so we get 8 matches there. Math, counting, how do I do it? This one, it can be a little hard to see. I apologize with the font here. This is a lowercase w. This is an uppercase W. You can kind of tell it's a little taller. We're looking for not letters, not numbers, not underscores. And we didn't find any of those here because these are all letters and numbers, which are word characters. So we don't find that one. In this example, we have 3 tildes, the little squiggle when you go shift backtick. This is a lowercase w. Are any of those word characters? Nope, because we're looking for word characters and those are all not. But again, uppercase W, we're looking for things that are not numbers, letters, or underscores. And that's true because that's not a word character. That's not a word character. And that isn't either. They're all not word characters, which does match the not word character pattern. I know it's kind of like doubles and triple negatives here, so it's a little weird to get your head around, but that's kind of how regex works, and that's what she signed up for. So here we go. Let's keep it moving. The caret and the $sign do not need to be modified with the backslash in order to have special meaning inside a regular expression. The caret, that's what this character is called, shift 6 on the keyboards I'm familiar with, and obviously you're familiar with the $sign, shift 4. This is the start of the line. This is the end of the line. And so without having to modify them, we just look for this pattern here. This returns true because we're looking for the literal characters of the word value, and then we're looking for the end of the line immediately following that. So that's our pattern. We're looking for these letters followed by the end of the line. And there's those letters in the exact order we're looking for. And then I'm highlighting this single quote. It's not technically part of the match because that's just PowerShell's way of wrapping strings, but I needed a character to get highlighted and match that $sign. So representing the end of the string here, we found our pattern, and this is the match. Quotation mark doesn't work here. That's not part of the match. The match itself is just value because end of the line is a 0 with character. That's not actually a character that you can like type on your keyboard other than just hitting a carriage return, right? Like that's just the termination of the line. And so it's not part of the actual match that you get back. In this example, we're switching it up a little bit. This one returns false because we're still looking for those characters in order. But before that, we're looking for the start of the line. That's what this caret means. And so as PowerShell is going through and performing this matching operation, it's going, okay, here's the start of the line. And then, whoop, that's not what I'm looking for. That's an S. I'm supposed to have a V that comes after that. And it just says, didn't find you. It doesn't keep looking because there's only one start of the line, right? Like it doesn't keep iterating through this. That there'd be no point in that. And so that's why this one's true, because there's value and then the end of the line. And this one's false because there's start of the line, but then something else.
I think the lesson there too is just to make your point is that even if value $ is at the end, it would be false with the second line too, because
yes,
again, it's
right.
not the end. So just want to point that out.
Yeah, absolutely. Good call So back into some characters that are modified with the backslash to get special meaning. The lowercase s and uppercase s are for and actual white space, which are exactly what they sound like. These are spaces and tabs and just characters that take up width but are white space. So in this example, that's lowercase s. This returns true. And you go, but wait, there's all these characters that aren't white space. Like none of those are white space. But we did find that pattern twice in these two spaces right here and there. And so this whole thing returns true. And if this was not just Boolean matching, those spaces would be returned as the value of the match. In this one, I don't have any spaces in between these words, so it returns false. In this one, it's a little hard to see. There's a single quote, and then there is a space character here, and then another single quote. We're asking if that matches \capital S, so not white space. And that's false because all it contains is white space. And so the chat was talking a little bit about escaping and how some of that works. So let's consider this example. This one right here. Does this return true or false, given everything you know about regex so far? Whatever you came in with and what I've taught you here, we've got our pattern right here, \, then slashes. And like visually, I can see this, \, and then slashes. And so make a bet with yourself. Does this next line right here where the laser pointer is, does that return true or false? 3, 2, 1, it's false. And you go, wait, but I can see it. It's right there. How can this be false? Because remember that the \ has special meaning. And so it's not a literal \. \ is our magic wand. And we're using it right here to bonk the thing that comes after it, give it special power. Here's our S, right? So what does this mean altogether? We just covered this one. That means a space. So our pattern is a space, and then the rest of these literal characters. None of these are modified. They mean what you think they mean. And so you can see, like this isn't how regex would parse this expression, but you can see the blue part matches. But what comes before it is a literal letter S. This isn't a pattern. This is just a string. This is text. These are all literal characters. But on the right, this is a regular expression. This is a string that contains special characters and meaning. So we have a \s here, but that's a literal S and not a space. If we had like this, well, this is true because this is the exact same pattern we had before, the same regular expression. And there's our space, and there's the rest of our letters. But which are you more likely to get, right? So this matches, and the space is part of that match. This white space is part of your match here. What you have to do is use the \ on itself. So here we have \, and this technique, like it was mentioned in the chat, is called escaping. Here I'm escaping the S. Putting a \ before any character is escaping that character in regular expressions in PowerShell. And so if I use it on itself, if I escape the escape character, it's saying, hey, normally this / is a special character with special meaning. This thing that comes after it is a special character. I want to take that power away. Just like right here, it says, this is a normal character, but I want to give what comes after me special meaning. I want to give what comes after me no special meaning. I want to toggle its special meaning on or off, basically, is what it's saying here. Hopefully that makes sense. So what you end up with is return a true here, because you have your literal text, you have your escaped \, and then this is just, again, literal text here as well. So you have your literal text, and then your escaped \ is just as the \.
Hey, Thomas, question for you.
Yes.
So in the first example, so I understand everything you're saying. The way you painted the first example, you had the \s, and you said that's a space, and then it had to also match lashes. But the way I read that is I read it left to right. So when this checks this, does it look and say \s, which is a space? I see no spaces in here and I move on. I don't even check for the lashes.
Yeah, that's exactly how it works. In reality, when PowerShell is actually performing the calculation and doing that activity, I was just kind of using that to paint the picture
Gotcha.
of how you would look at it as a human.
Okay.
But that's absolutely right. Like it's going to go, okay, my pattern is backslash X, that's white space, and then the rest of these characters. So it's looking for that first, and it's going, oh, I'm not finding it, 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 false. And you're right, it's not really caring what the rest of the characters are because it's a non-starter because the white space isn't there to begin with.
Okay.
But say like you had white space right here or something, or before this in like part of the string that comes off screen, then it would look at all those white spaces and see if the rest of it was there, but it's not. Good question. And that's why you can kind of come up with more and less efficient regular expressions too, which is not a for noobs topic. But on this last one, what the backslash giveth, the backslash taketh away, right? It either gives special meaning to what comes after it, or it takes it away if it has it by default. So in all these examples we already looked at, the S did not have special meaning, so it was given special meaning with the backslash. In this example, the backslash is a character that has special meaning. It manipulates what comes after it, and we used it on itself to take away its own special meaning. So hopefully that makes sense. We'll look at a few more examples here as we go forward. And there's more than just that. We're not going to talk about them all now because we're already more than a half hour in, and I don't want to melt anyone's brain too much and be respectful of your time. But we do have to talk about brackets and braces and all whatever you call them. There's 3 different types that I'm going to introduce to you: round, square, and curly, which we'll just dive in. Curly brackets are like a custom quantifier. Remember, our quantifiers are the star, the plus, and the question mark, 0 or more, 1 or more, 0 or 1. And the curly brackets allow you to be more precise. So you have something like this, where you have your string here on the left, something 1, 2, 3, and then match. We know what this is, backslash D. Well, that backslash gives the D special meaning, and together it means a digit. And then the curly braces, I told you, are like a quantifier, so it applies to whatever comes immediately before it. And in this case, we're saying we want 3 of what comes right before it. So what are we looking for? Numbers. How many of them do we want? 3. This could have been a star for 0 or more. It could have been a plus for 0 or more, but it's not. It's a 3 wrapped in curly braces. And this returns true because I'm looking for a number, but I'm looking for 3 of them. So that's not a match on its own. That's not a match on its own. But this is a match because it's 3 of them. So before, when I just had the 1, 2, 3, and I just had the backslash D with no quantifier, all 3 of these were matches. But that's not how we're working now. We're saying I want 3 of these. I want a specific quantity of these. And I'm doing that with the curly braces. Similarly, like if I do this, exact same example, but instead of 3, I've got 10. That's false because I'm looking for a number. I'm looking for 10 of them, and I've only got 3 there. So I didn't find this pattern of 10 numbers in a row. And you can see how this starts to kind of build on itself and become more customizable for you. When you look at more in the curly braces here, if I put a comma and 2 numbers, what this is saying is, this is still one quantifier. This is still quantifying the backslash D, but it's saying between 2 and 4, including 2 and including 4. So more or less than 2, or sorry, more or equal to 2, and fewer or equal to 4 of this pattern. And this is true because we're looking for a number 2 to 4 of them. Well, that's only 1. Well, that is good. That's 2. And 3 is between 2 and 4. And then we run out of stuff, like the end of the line happens. But that pattern is found. You can leave the last number off as well. And this is still the exact same quantifier, same example, same number, same quantifier activity, but this is saying between 2 and infinity. So this is really like saying 2 or more of something. And so it's like a plus sign, which means 1 or more, but we're saying 2 or more. So we're doing that custom quantifying right there. Yeah. So there's 2 or more of them right in a row there.
So go back to the idea too that the top one. So if it went to 1, 2, 3, 4, 5, 6, 7, 8, 9, it would still match, even though it's truly only matching on the first 3, even though there's more than 1, 2, 3, 4, 5.
Right. It's kind of one of those, you can't make 6 numbers in a row without having 3 numbers in a row.
Yeah.
And so it's finding 3 numbers in a row several times.
Yeah.
So it would still say true.
Okay.
Round brackets are used for grouping, so you can almost think like algebra here. It's saying treat everything inside the round brackets as a group, and that's handy for things like quantifiers, right, which apply to whatever comes right before it. Again, apologies for the wrapping here. I just changed the font on this. But what we have here is hello 1 2 3, hello 1 2 3. All that's our input string, and then match. Imagine this was on the same line. Sorry for that. We have hello 1 2 3. But it's wrapped in round brackets. And then we have a quantifier right here of the curly braces with the 2 in the middle. So what this is saying, this returns true, because I'm saying this hello 1 2 3, this quantifier, apply the quantifier to this whole thing encased in round brackets. We're applying it to this group. Round brackets are referred to as grouping, like I've got here. So it's saying this whole thing I need to refer to as one thing, usually for a quantifier that comes after it, sometimes for other reasons, and depending on what you're doing with your matches afterwards, this can have other implications as well. But in the for noobs section here, this is basically just saying treat everything here as one group so that the quantifier that I put after it can apply to the entire group. So it's going to say, hey, there's my hello 1 2 3, and yeah, I have it twice in a row, because I'm looking for that whole thing twice in a row, and it's finding that pattern. This top string, the entire thing is one match to this one pattern. Square brackets are to denote a set of characters, which I'll illustrate here with an example. The square brackets are saying, I want either this or this or this, or like one of anything that's in the square brackets in a 1 character space. And so we'll illustrate that here. This returns true because the end of the line is going to be the end of the line, right? And so what I'm really saying is the last character is the character that comes before the end of the line, F or G or H. That's what this says. It's saying F or G or H in a 1 character space, and then the end of the line. Give me my mouse. So end of the line, and then in 1 character space, let's see what it has. Does it have F or G or H? It sure does. So that's my match. And again, that's not necessarily how it would perform that calculation. It's just how you can think of it in your head. It'll take like, hey, is this an F or a G or an H? Yes, no, it's not. Is this? And then it finally finds one. And then it checks to see if the character that comes next is the end of the line. You can use this dash. Outside of the square brackets, dash doesn't have the same meaning. But inside the square brackets, it's a range operator. So this says between F and Q inclusive. So between an F and a Q and then the end of the line. This is still a 1 character space though. So this is true as well, because I'm looking for the end of the line and then a character between or including F to Q. So there's my end of the line, and G is, yeah, it comes after F. So that's between F and Q. So I find that right there. Here's another example though. This one's false because I'm looking for the end of the line, and the character before it has to be between H and Q. And G comes right before H if you remember your alphabet. And so end of the line, but that's a Q, which is not between H and Q. Sorry, that's a G, which is not between H and Q, so that's not found in there, which is why it returns false. So it's really valuable when you want to say, this could be like 11 different characters. I don't know which it's going to be, but it's got to be one of them. So you enumerate them with a set here. Carets have special meaning when they're just in a regular expression, right? They mean the start of the line. But when they're inside of square brackets, they have a different special meaning, which is really helpful for people who are trying to get started learning this. In this example, this is true. And you go, what, why, how does that work? Because normally you'd read this and go, I'm looking for the caret, so maybe the start of the line, or a Q, or an R, or an S, and then the end of the line. And you go, how is that true? Because end of the line is right here, and that's a G, which is not a caret, not a Q, not an R, and not an S. So how is this true? It's because inside square brackets, carets are special. They negate the set. They invert it. They say not anything that's in these square brackets. So not Q, not R, and not S. And then the end of the line, which G satisfies. So end of the line, not a Q, R, R, S. There's the end of the line. There's my G, which is not, highlight special, Q, R, or S, which is why that's true. In this example, we're saying this is false because I'm looking at the end of the line, looking at the last character. It's got to be not G and not H, but it is G, which is not G, right? Again, I know double negatives, weird, but here we go. Let's look at a couple of examples here. Let's see if we have some time. Isolating a username, and again, freaking wrapping. Here's the string, domain / username, probably a pretty familiar kind of pattern. You see a lot of this in your environment, I'm sure. And we're replacing the pattern \w + / with nothing. So we're just stripping, like if we find this pattern, replace it with nothing, right? Remembering that from earlier slides. And this returns just the literal text username. How does it work? You know how this works. We just talked about all of this. \w is a word character, right? Letters, numbers, underscores. And we want one or more of them. And then \\, that's a relatable example. Normally we see the backslash and we go, oh, it's going to give special meaning or take it away from whatever comes next. What comes next? Well, \. So that means literal \. So there's our word character. There's one or more of them. There's a literal \. And that's what we're replacing with nothing, right? So we found our pattern, and we replaced it with empty quotes. We replaced it with nothing. Let's do another. I've talked a whole bunch about how you can do better than just Boolean matching and work with the value that's actually matched. In this example, I'm using the regex class that comes in .NET, and I'm using the matches method on that class. And it takes, it's got a number of overloads. It can take a bunch of different things. But in this example, I'm passing it the string that I'm interested in looking at, and I'm passing it my regular expression as well. And then I'm hitting enter, and what it returns, what do you think it returns? It returns an object. It doesn't just return a Boolean, it returns like a regex match object with groups and names and captures and a whole bunch of stuff that is very interesting if you actually are performing this activity. And so my regular expression, though, touching on this again, is \w, so a word character, one or more of them, and then the end of the line. And so this method is going to go, there's a word character, there's one or more of them. Oh, it's not the end of the line, it's a \. Does it just give up? No, it will not be deterred. It's going to look again and it's going to go, oh, that's a word character. That's one or more of them. And that is the end of the line. So I did find my pattern. I found it right there in the word username. And that's part of the match that gets returned here. You can see that's the actual, just the value. If we had used our regular expression for the previous example where we were stripping out this other part, it did match this. So it would return that. In this example, we want to match the word username, not the earlier part here. And so if you want to isolate that and you're not that familiar with PowerShell, just append .value to access that value property, and it'll just return the text, right? First time I gave this was not for a PowerShell user group, so I wanted to make sure that was present for them. Parsing HTML, oh, buckle up. This one's gonna, just kidding. Don't ever parse HTML with regular expressions. It's not the right thing to do. It's never the right thing to do. I promise you, it's, just don't. I won't go over it a whole bunch because I don't want to blow a bunch of time on it, but just don't try to parse HTML with regex. Like the slide says, it's super powerful, but there's better tools for doing this, and it's a common pitfall beginners get into. They do things like, I'm going to strip the tagging out of this paragraph and strip out all the divs and spans and anything inside an angle bracket. I'm just going to, no, it's wrong. Don't do it, please. You'll thank me later when you find a better way to do it. Or if you do actually try parsing HTML with regex, once you're done or give up, talk to me on Twitter about what a fun experience it was and remember this slide. Another example, is that an IP address? This one's going to look like I'm throwing you into the fire a little bit because you're going to go, what's happening here? I'm looking to see, is this string that I'm taking in contain this pattern? You're going, holy crap, we've just gone from Little Red Wagon to Rocket Ship here in terms of difficulty. This is, but you know exactly what this all means. We talked about all of this. So let's just kind of go through it methodically, shall we? First, it returns true. We do find that pattern in there. So where the heck is it? Because this doesn't look anything like this, which it kind of has for a while here. We're saying digit. You know what that is. Like, let's just read it left to right, right? And knowing that this curly brace means that there's going to be another curly brace and that whatever's in them is a group. But the first thing of real consequence is digit, okay? I got a digit right there. It's a 1. And then I got a quantifier that comes after it in my curly braces. I'm saying 1 to 3. So between 1 and 3 digits. Yeah, I got between 1 and 3 digits right there. And then what comes next? A backslash. Okay, well, I know backslash gives and takes away meaning of whatever comes next to it. It escapes the next character. And I know that the next character is a period, and a period matches any character when it's on its own. So if I'm escaping it with a backslash, remember what that does? It's either giving special meaning or taking away special meaning. In this case, it's taking away special meaning because it's the period that would normally have meaning without it means any character. So I got a literal period, comes right after my 1 to 3 numbers. And then that's a group. So that pattern of 1 to 3 numbers followed by a period, I want that 3 times in a row. There it is. I got 1 to 3 numbers and a period, 1 to 3 numbers and a period, 1 to 3 numbers and then a period. So far, so good. And then just 1 to 3 numbers, right? This is a number, and this is 1 to 3 of them. And I find that right there. So that whole pattern I found right in my original string. Obviously, this is not how you would normally test for an IP address, because there's things like, what if this had invalid numbers? Like, what if this was like 6,000 or 641 dot whatever, and that was out of range? I'm just kind of using a more relatable example here. So what if you had something like this? We're not changing the pattern on the right at all. We're not changing the regular expression, but we're changing our input. This is false because I'm still looking for 1 to 3 numbers, which I'm finding, and I'm looking for my period, which I'm not finding. Okay, well, looking for 1 to 3 numbers, which I found, period, didn't find that. 1 to 3 numbers, no period. So I didn't find that pattern. I didn't have to go through all of this to know that this doesn't have that pattern in it. So again, looks intimidating, but break it down into its parts. You just kind of eat it one spoonful at a time here. You dissect it. Okay, well, backslash manipulates, oh, that's a okay number, and then, oh, that's a quantifier. It applies to the thing that comes before it, which is a number, and you can kind of work through these. And it takes a little bit of time, but you'll get quicker at it as you practice. And then one last tool I want to call out is regex101.com. Super valuable tool for testing and developing regular expressions. In particular, like this part of it here, allows you to put in your regular expression, which looks familiar. This is the one that we were just looking at. And then it gives you your test strings that you can put in here. So I put in both of my examples to see which one's matched or not. And then on the right here, it even breaks down in English what's happening in your regular expression. It's highlighting this D and this 1 to 3 and it's saying D 1 to 3 matches a digit 3 times, between 1 and 3 times, etc. And so it goes and it breaks down the rest of it. It's not originally for .NET languages like PowerShell or C# or anything, but regular expressions don't really change much between different languages. They look the same in like JavaScript and Python and stuff like that. So that's everything I've got for you. I've got a couple of minutes for some questions, but I'll have to get it moving pretty quick hereafter. But thanks very much for all your attention, and I hope you go and use regular expressions in every single use case you possibly can, except for parsing HTML.
So let's just hang on there 1 second.